Okay, so this is the solutions video to the first assignment. So, first question, solve each equation for x. So, first thing I'm going to do here at 1a is I'm going to combine these two fractions, bring them together. I'm going to multiply the one on the left by, not 3, by 6, top and bottom. Actually, I'm going to do this a little bit differently. I'm going to multiply the left one by 2, top and bottom. And I'm going to multiply the one on the right by 5, top and bottom. I did this to get the same number in the denominator, and I just chose 30 because I knew that it has factors of 15 and 6. So now I'm going to bring the two fractions together, actually add them, so I get 7 over 30, and just bringing my solution up over here. I'm now going to flip both sides, so I get x equals 30 over 7. So that is 1a done. For b, 1b, I have I'll leave the 12 alone for now. I have that -4. I'm going to distribute that throughout the brackets. So that first one becomes positive 24x plus 12. I'm going to subtract 12 from both sides. So this becomes 0 equals 24x. So therefore 0 has to be equal to x. Divide both sides by 24, you get 0. 0 divided by anything other than infinity, just 0. All right, so now we have 1c. In this one, we have 132, and if we subtract 2 times y squared from both sides, that cancels it out, and we are just left with x on the right. This one, a little bit simpler than it just appears at first. 1d. In this case, I'm going to start by subtracting 21 from both sides. So I have 100 equals 4x squared. I'm going to divide everything by 4 first. So I'm going to have 25 equals x squared. I'm going to write this backwards. X squared equals 25. I'm going to square root everything. So I'm going to get x equals, now plus or minus. There are two possible solutions here because I'm taking a square root. 5. Square root of 25 is 5. Positive or negative. So if you square -5, you still get 25. So that is our solution there. And 1e, I'm going to start by multiplying everything by positive 4 here. And that will give me 8 on the left. That's a terrible 8. 8. And x minus 4.5 on the right. I'm going to add 4.5 to everything, and that will give me 12.5 equals x. That's our answer there. F, for F. Multiply everything by 3. That will give me 21.6, I believe, equals 28 minus x. I'm going to add x to both sides. So 21.6 plus x equals 28. This is just because I like having the variable I'm solving for be positive. And then I'm going to subtract 21.6 from both sides. So I have 28 minus 21.6. And that will get me, I believe that is 6.4. Yeah, 6.4. Okay. Had to double check that in my head. This time, because x is in the denominator, I'm actually going to start by moving x first. I'm going to multiply everything by x so that it cancels out on the right-hand side. So I'm going to have 3.5x equals 25.7 minus 4.5. I am going to have x equals, we'll do it this way first, 3.5x. I'll do the subtraction first. This is going to be 21.2, and divide everything by 3.5 now. So 21.2 divided by 3.5, and that works out to be about 6. About. It's got a decimal, but I'm looking for a correct method right now, not exact numbers. As long as you got the correct method, I gave you the mark for that one. In this one, now x is in the numerator, so I'm going to leave x where it is for now. And because of that, I'm going to start by multiplying everything by 4. So I'm going to get 44 equals 12 squared minus x squared. 12 squared is 144. I'm going to subtract 144 from both sides. So this is negative 100, negative x squared. Now, if I multiply both sides by negative 1 times negative 1 times negative 1, I will get 100 equals x squared. Now I'm going to square root both sides, and I'm going to get plus or minus. Again, because I have a square root, we could have positive 10 squared or negative 10 squared, getting us back to that 100. So we have two possible answers here. So that is everything for page 1. Page 2. Find the slope of each line. So I'm going to count how many times we go down 1. So we got 1, 2, 3, 4, 5, 6, 7, 8. So I know this is minus... Oh, I counted one past. It's actually 7. My bad. So that's down 7 and over 1, 2, 3, 4, 5, 6, 7, 8, 9. We go to the right 9, so that's positive. And we go down 7. Slope, 2 formulas there. One of them is slope m is just equal to the rise over the run. In this case, our rise is negative 7, and our run is 9. So the rise is how high up or down it goes. The run is just the other one, or how far left and right it goes. So in this case, our slope is negative 7 over 9. Cannot reduce that any farther. For b, I will use the other formula on this one. Our rise is 1, 2, 3, 4, so negative 4. And our run is 1, 2, 3, 4, 5, 6, plus 6. So we could use the rise over run formula and get negative 4 over 6, and then reduce that to negative 2 over 3. Or we can look at the coordinates of the points. So the coordinates of this first one, this first point, it is over 1, 2, 3. So it's over 3, negative 3 in the x direction, and it's down 1, so minus 1. The coordinates of the first point. Coordinates of the second point, we are over 1, 2, 3, positive 3, and we are up 1, 2, 3 as well. And our other slope formula is slope equals y2 over, or minus, sorry, y1 over x2 minus x1. And plugging in my numbers, point number 2, y value is positive 3. Subtracting the y value of the first one, which is negative 1. So minus negative 1. And same thing with the x values. So x2 is 3, minus negative 3. Top, that's actually going to become positive 4. So when you take away a negative, it becomes a positive. Over, same logic on the bottom, 6. And that reduces to 2 over 3. So we get a slope of positive 2 over 3. I think earlier during this problem, I misspoke and I said the slope would be negative. It is positive. I believe I misspoke just about a minute ago on 2b here. So it is supposed to be positive. I think I said it was negative. I'm sorry. Quickly, I'm going to just box off these solutions here just to clearly show which ones are with which side. So I will do my rise over run method again here. So our rise is down 1, 2, 3, 4, minus 4. Our run is 1, 2, 3, 4, 5. This is plus 5. So negative 4 over 5. So this is rise, this is the run. And the slope comes from the rise divided by the run. In this case, leaving it as a fraction is perfectly valid. If you would instead rather write negative 0.8, I'm fine with that too. I gave you the mark either way, no matter how you did it there. Let's use the other method on 2D here. So our x is 1, 2, 3, 4, negative 4, and 0. And our second point is 0, negative 1. Slope formula, y2 minus y1 over x2 minus x1. Y2 is going to be my negative 1. I'm going to subtract 0. x2 is going to be 0. And I'm going to subtract negative 4. So that will become positive. So at the top, I'm left with negative 1, because negative 1 times, or minus 0 is just negative 1. And 0 minus negative 4 becomes positive 4. So my final slope here is negative 1/4. That is it for question 2 there. Question 3. Solve the following system of linear equations by substitution. So I'm going to just divide my page. And I'm going to choose a slightly smaller ink here. So first thing I'm going to do is I like to make sure I label my equations in these. So I'm going to call this equation 1, this equation 2. And as a little reminder to myself, I like to write down what it is specifically that I'm going to do. First thing I like to do is make sure that one of my equations is solved. So it just has one variable on its own on one side of the equal sign. In that case, we don't have to do any extra work because equation 1 already has y by itself. So that's perfect. So I'm going to substitute, that's what sub is going to stand for here, sub equation 1 into equation 2. So what that's going to look like is I'm going to have the 2, and instead of writing y, I'm going to write what y is equal to in equation 1. And I will write the rest of equation 2 as normal. So now equation 2 only has x's in it. So first I'm going to expand those brackets. I will get 10x minus 2. Remember that 2 goes to everything in the brackets. And I did not do anything to the right-hand side. Now I'm going to bring my x's over to the left, and I'm going to bring my whole numbers over to the right. So I'm going to subtract both sides by 3x, and I'm going to add 2 to both sides at the same time here. So I'm going to be left with 7x equals 14. Dividing both sides by 7 will give me x equals 2. Now this is not the final answer. We're only halfway done. Solving the system means we figure out what x is equal to and what y is equal to. So now we are going to take this answer and we are going to sub x equals 2 back into one of the two original equations here. I'm going to choose equation 1 because y is already by itself. Just a little bit simpler for us. So y equals 5x minus 1. I believe that's what it was. Yes, 5x minus 1. And instead of writing x, I'm going to substitute in 5 times 2 minus 1. Y equals 5 times 2 is 10, minus 1. Y equals 9. And there is 3a done. 3b. So I'm still going to call this equation 1 and equation 2. However, first thing I'm going to do is I'm going to change how my equation 1 looks. I'm going to subtract both sides by 2x first to get y equals 7 minus 2x. And I'm going to call this equation 1. And this one I will leave as is, call it equation 2. Actually, wait, never mind. Oh, sorry. Confused myself for a second. Thinking too far ahead. Substitution. So now I'm going to sub equation 1 into equation 2. So what that will look like, we write equation 2 normally, but instead of writing y, I will write what y is equal to in equation 1. Perfect. So now I'm going to distribute that negative 2 throughout the brackets here. I'm going to leave the 3x normally, and I got negative 2 times 7, so negative 14. Negative 2 times negative 2x is going to be positive 4x, and that's still equal to negative 7. I'm going to add 14 to both sides, and I'm going to bring the two terms with x's together. So I will have 7x equals positive 7 now, because negative 7 plus 14 will give me 7. So adding 14 to both sides there. Divide both sides by 7, you get x equals 1. Again, not done. Need to substitute this back in to find what y is equal to. In this case, let's use equation 2 this time. So we will sub x equals 1 into equation 2. And equation 2 is 3. Now instead of x, I'll put a 1 minus 2y equals negative 7. And 3 times 1 gives you 3, minus 2y equals negative 7. Take away 3 from both sides, left with negative 2y equals negative 10. Divide both sides by negative 2, y equals positive 5. So our answer here is x equals 1 and y equals positive 5. So that is question 3, A and B both done. On to question 4. Earlier when I started 3B, I thought I was doing elimination for a quick second, so that's what I was caught up on. But now we're doing elimination. So now, solve each of the following systems of linear equations by elimination. So this time we are not reorganizing our equations to solve for specific variables. This time we're going to do something different. So I want at least one of my variables to have the same coefficient, so that when I add the two linear equations together, they cancel out. So in this case, I have equation 1 and equation 2, just like last time, but I'm going to take 2 times equation 1, and I'm going to add that to equation 2. Now, what that looks like is equation 1. Instead of just writing x, I'm going to write 2x minus 2y equals negative 12. You multiply the entire equation by 2. Now, equation 2, I'm just leaving that as is. So I'm left with negative 2x plus 3y equals 16. Leaving that one untouched. Now, I did this so that my two x's would cancel out when I add these two equations together. So there, my 2x plus minus 2x just cancels out. It gives me 0x. So that's gone. In this case, I got 2y plus 3y. I'm going to be left with positive 1y. And negative 12 plus 16 is going to give me positive 4. So usually you have to do a little bit of rearranging and simplifying when you get to this point. But in this case, I actually got lucky. So we got y equals 4 first. And now we can... So that was the elimination part of this. Now we can sub y equals 4 into... I'll choose equation 1. Into equation 1. So I get x equals... Or not x equals... x minus... And we sub in 4 for y. Equals negative 6. So that is x minus 4 equals negative 6. And add 4 to both sides. X equals negative 2. So that is for A done using elimination. For B, so this time I will cancel out my y instead of x. So again, I'm going to label this equation 1, equation 2. And to get these two y's to have the same coefficient, I will multiply equation 1 by 2. So I'll have 2 times equation 1 plus 3 times equation 2. Now I'm choosing this so that my coefficient becomes 6 in front of both. So 2 times equation 1, that's going to give me 10x minus 6y equals negative 2. And equation 2 will become 9x plus 6y equals 21. Now, I'm adding these two equations together. It is perfectly fine to subtract them, but in that case, both of your coefficients on the variable you are trying to eliminate must be the same sign. So the way you decide whether or not you add or subtract is based off of what sign you choose your variable to be. Personally, I prefer adding them together to cancel it out so that my variables look like they cancel out better for me. It's just how I prefer to do it. If you prefer subtraction, go for it. It's just as good. In this case, 10x plus 9x is 19x. This is going to be 0 equals 21 plus minus 2, or I guess minus 2 plus 21. Either way, positive 19. We are going to get 19x equals 19, and then divide both sides by 19, x equals 1. So this time we did have to do just a little bit of rearranging after the elimination. And now I'm going to sub this value back in. So I'm just going to write that over here because I have more room. Sub x equals 1. Sure, let's plug that into equation 1. Into equation 1. When I'm subbing back into the original equations, I'm not choosing them for any particular reason. I'm just choosing them because one of them looks like it's easier than the other sometimes. So, in this case, I have 5 times 1 minus 3y equals negative 1. So that's going to give me 5 minus 3y equals negative 1. I'm going to subtract 5 from both sides. So negative 3. Y equals negative 6, because I'm subtracting. And I'm going to divide both sides by negative 3. Y will be positive 2. So that is question 4 done using elimination. Now, question 5. Use the Pythagorean theorem and primary trigonometric ratios to solve each triangle. Now, to solve a triangle means to find every side length and every angle, not just using the Pythagorean theorem. So I've sectioned off my 3 parts of the question here just to make it more clear what part is going with what part. So, A, I have 10 meters and 15 meters for each of my side lengths here. So I'm going to start by finding the last one using the Pythagorean theorem. So I'm going to call this, let's call this side length A because this is part 5A. So I'm looking for A squared, and I know that this is going to be the 2 other side lengths squared added together. So I know that A squared is going to be equal to 225 plus 100, and then A is going to be equal to the square root of 325, which I'm going to grab my calculator for, because I don't feel like making a mistake halfway through this video like that. So the square root of 325 is approximately 18. So the numbers I gave you here have 2 significant figures. So I will write my answer with 2 significant figures. So side length A is 18 meters. So now, I must use primary trigonometric ratios to find the missing 2 angles. I'm going to call one theta. I'm going to call the other phi. And to give myself a bit more room, I'm just going to shrink this a bit. Put that over here. Okay, so for theta, I'm going to say that the tangent of theta is equal to 15 over 10. Now I'm saying that because in SOHCAHTOA, the TOA part tells me that tangent is equal to the opposite over the adjacent. So the opposite side from theta is 15. Put that over 10, the adjacent side. And I'm going to take the inverse tangent of both sides, or the arctangent is also a word for this. So we can call this the inverse tangent or the arctangent. It is known by both names. And this gives us, I'm going to shrink this first. Shrink. Oops, I did not mean to grab the 10 with it. There we go. Oops, there we go. This is going to give us, punching into the calculator, the inverse tangent of 1.5, because 15 divided by 10 is just 1.5. That's going to give us about 56. So I will say 56 degrees for theta. Okay, now you could say that phi is equal to 90 minus 56, and you'd be absolutely correct. You could do that. But I'm going to go ahead and use primary trigonometric ratios throughout this solution. But if you had done phi equals 90 minus 56, I would have absolutely given you the mark for that. So just know that is an option. I'm not going to bother taking the shortcut in this video, though. So in this case, I know that phi, or yeah, I can take the tangent of phi again. I'll use tangent again, but this time it'll look a little different. This time the tangent of phi, again, this is opposite over adjacent, but this time the opposite is 10 over 15. Take the inverse tangent, so we have the inverse tangent of 10 over 15. Which will give us about 34, that rounds up to. 34 degrees. Which, if you go ahead and do 90 minus 56, if you already did that, you would see that you would have gotten 34 as well. 34 degrees. Both ways work. So that is 5A done. 5B. Again, I'm going to start with Pythagorean theorem. This time I will call this side B for part B. So I'm looking for part B, side B. In this case, I have the hypotenuse. So I am going to write this as 30 squared equals B squared plus 25 squared. So that's going to be 900 equals B squared plus 625. Subtract this from both sides. I'm going to be left with 275 equals B squared. And square rooting both sides is going to get me 16.58. Again, two significant figures here, so I'm just going to round that up to 17 meters. Some of you may be noticing that I did not consider the possible negative answer to this solution. That is because in a real triangle, in the real world, a negative distance just does not make sense. It's impossible. So I have ignored the negative possibility in so far both of these triangles, actually, and I will continue to ignore that throughout this problem. Just because in the real world, negative distance just doesn't really make too much sense. You can have one, but that's a chat for another day when we hit kinematics. So, angles time. I'm going to call this one theta, and I will call this one phi. I'll go for phi first. I'll find phi. So, for phi, I have the adjacent and I have the hypotenuse. So, adjacent and hypotenuse will give me cosine of phi. Again, I'm choosing this based off of SOHCAHTOA. 25 over 30. Take the inverse cosine of both sides. Still 25 over 30. Can reduce it if you really want to, but I'll leave that up to you. So the inverse cosine of our 25 divided by 30 gives us 33.557 and so on. Again, I'm going to round this, say 34 degrees. Perfect. So for theta, again, you could do 90 minus 34, and then you'll get 56. But in this case, I will go ahead and use a primary trigonometric ratio. I'll use, why not cosine this time? Or, yeah, I'll use cosine again. I'll try to use sine on the next one then. 2 of each. Okay, so cosine of theta equals our adjacent side here is the 17 that we just calculated over the hypotenuse, which is 30. Again, take the inverse cosine of both sides, 17 over 30. And that should give us the same angle we got on the other side, which is 56. And I don't know about you, but if I don't punch that in my calculator right now, I will go insane. And I will doubt myself until the day I die. And 55.48, so I guess technically this would round down. But I'm going to leave that as 56. So I guess I should say 55 if I rounded that correctly. Again, I'm not looking for exact, perfectly correct solutions here. Because of the rounding, these numbers will be off a little bit. And sorry, if you heard that thud, that was my cat, Sally. 5C, last one here. I will do another Pythagorean theorem quick. So our hypotenuse is 25 equals 7 squared plus, and I'm going to call this side C, because we're just on part C. So we get, that is 625 equals 49 plus C squared. So if I subtract both sides from 49, I get 625 minus 49, which is 576. Square root both sides. I got the square root of 576, which is exactly 24. Okay, I will call this angle theta, this angle phi, and this time I said I would use sine. So let's use the sine of theta first. Now sine is opposite over the hypotenuse when you look at SOHCAHTOA. In this case, the opposite is the 24 we just calculated. 24 over our hypotenuse of 25. Take the inverse of 24 over 25. And that will give us, I will round that up to 74. Again, because the numbers are of significant digits in the question. And again, you could do the 90 minus 74, figure out phi, but I will show the calculation. In this case, our opposite is 7. That is the opposite side to phi. Our hypotenuse remains the same. We do the inverse sine function. And that leaves us with 7 divided by 25, which gives us 16 point some stuff. Round it to 16. So I believe that was all of question 5. Yes, all of question 5 done. So on to 6. This one is very similar. I'm going to divide up these questions in a way that gives me some good space for all of them. And I'll put that kind of down the middle. Okay, get rid of the ruler now. Okay, so that gives me some solutions here. Or some space for solutions, I should say. So, use sine and or cosine laws to solve each triangle. So, and or, use them however you want. This first one, it is set up specifically for cosine. I'm going to call this angle side A. It's part A. And our cosine law is side A equals b squared plus c squared minus 2bc cosine the angle of A. So in this case, we're going to have A squared, that is the side we are looking for, equals, I'll call B side 8 squared plus 11 squared minus 2 times 8 times 11, there we go, times the cosine of 37 degrees. And again, I don't think I mentioned this. Be careful with degrees. Some of your calculators or some online calculators might assume you are using radians and give you a wildly wrong and different result. Not necessarily wrong, but different than what you may have expected. So that will leave me with A squared equals, that's going to be 64 plus 11 squared, which I think is 121. Either way, that gives us 185. 2 times 8 times 11, 176, so minus 176. And I will leave cosine of 37 degrees on its own for now. And the cosine of 37 degrees is 0.798635551. I ran over my corner a little bit there. That's okay. The reason I'm not rounding this just yet is because this is not my final answer. So I want to save as much precision as I can. This gets multiplied by 176. So I end up with A squared equals 185 minus 140.5598498. Now, I'm sure this decimal goes on longer. I'm rounding it off to this specific point because that's just the number of decimal places my calculator shows me. So I now have 185 minus this 140 decimal. That gives me A squared equals 44.440150.2. Square root both sides. A equals, and again, we're just going to take the positive result of this. So square root of 44.44015.2 gives us about 6.666. I'm going to call that just 6.6. So that is our side length here. Actually, I'm gonna move these lines off to the side for now because I'm going to shrink this. Oh, if I grab that, I will accidentally take the number 8 with me. Okay. There we go. That's better. That's more in the middle now. Okay, back to sine law. So now, general form of sine law, down here on this page, on the top right there, on the right side. Sine A over A equals sine B over B. That is our general form. So we need to find angle theta, angle phi. That's what we need to find. So the way they are connected is opposites. So theta goes with 8, phi goes with 11. Let's look for 8 first. So I know that the sine of theta over 8, that is a messy 8, is going to be equal to, I'm going to choose the sine of 37, the only other angle that we know, over the number we just calculated, 6.6. Now, if you want to get some really good, accurate results, you should keep a big long decimal and input it here just as exact as you can. I'm not going to, so our final answers might look a little bit different. Again, I'm marked looking for method, not for the exact same numbers. So if your numbers don't look exactly like mine, that's fine. Depending on how much you round, your three angles might not even add to 180. They might add to more, they might add to less. Again, I didn't care if that was the case. I just marked if you used the correct method, if you used sine law correctly, if you used cosine law correctly. So in this case, I'm going to start by multiplying both sides by 8. So sine theta equals 8 sine 37 over 6.6. Theta equals the inverse sine of 8 sine 37 over 6.6. Now you can put this whole thing in your calculator just like this if you use your brackets correctly. If not, just punch it in one by one, step by step, and not all at once. So I have the inverse sine of 8 times the sine of 37 divided by 6.6. And here I will round that up to 47. 47 degrees. And that's my angle for theta. Again, as always, you could do 90 minus theta, or you could do 180 minus 37 minus theta, and then you know, not 90 minus, but 180 minus 37 and minus 47, then that would give you phi. So because this is not a right angle triangle, we could do this to find phi. However, I will do like that. That will work. However, I will do the full calculation here. Let me just shrink this down and put this over here. So in this case, sine phi over 11 equals, I'm just going to use the same sine 37 over 6.6, and using the exact same method as the previous question, and that will leave us with a final answer of 11 times the sine of 37 divided by 6.6. Oh, syntax error. I punched something in incorrectly to my calculator. Okay, I'm getting something weird here. So sine of 37 is 0.6 times 11. Divide that by 6.6 is 1.003025039. Okay. 1.003025039. Okay, yeah. Inverse sine, for some reason, does not like taking in a number larger than 1. I think I know why, but I'm not going to dive into that right now. So instead of spending my time pausing the video, figuring out where I went wrong, I will just use the method that I said was okay, which was this. So let's just do this instead, rather than you guys watching me troubleshoot stuff. So in this case, it's 180 minus 37 minus 47. 96. 96. If you want to know why the inverse of sine did not take a number larger than 1, feel free to ask me in class. I'd be happy to go over it with you. I'm just not going to bother doing that right now, this instant. So that is 6A done. 6B. Again, this is set up for a cosine law question. I will call this side A, because that's what it is in the formula. It's already set up for this. A squared equals 10 squared plus 12 squared minus 2 times 10 times 12 times the cosine of 62 degrees. So A squared equals, that's going to be 244, 144 from 12 squared, 100 from 10 squared, minus, that's going to be 120, so 240 times cosine 62 degrees. Now, this is not 244 minus 240. I saw a few people do that. This is 240 times cosine 62 degrees. So unfortunately, we cannot just do that subtraction. The multiplication must be done first. So in this case, the cosine of 62 times 240 gives us minus 1,126,731,751. And that should give us 131.3268249. Times 1. And now take the square root of both sides. Square root of both sides. And we get about 11. It rounds to. So that is 11. I'm going to call this angle theta, call this angle phi. No rhyme or reason to which one's which. Doesn't matter. They're variables. They are meant to be varied. I'm just shrinking this to give myself a little bit more room. Okay. So now I'm going to look for a sine law with theta over 10. And I will use the 62, the only other angle I have. Kind of have to. And put that over 11. Again, this 11 has been rounded. It's actually, the real number is actually a little bit larger. It's about 11.45. So my final answer might be a little off. But that's okay, we're rounding. Solving this the exact same way we did it previously. Sine 62 over 11. Theta equals the inverse sine 10 sine 62 over 11. And this will give us 53 about. It's actually 53 point stuff, but it rounds down. And again, you could do 180 minus 62 minus 53. But this time it should work out well for us. So I will do the proper calculation here. So sine phi over its opposite side, which is 12. I will use sine 62 over 11 again. We get sine of phi equals 12 times the sine of 62 over 11. And phi is equal to the inverse sine of everything on that right-hand side. So our phi ends up becoming 12 times sine 62 divided by 11. About 74 that rounds to. 74 degrees. So if you notice, 74 plus 53 plus 62 equals 189. So my angles are clearly a little bit off. They do not equal 180 degrees. That's okay. That is because I did a bunch of rounding here. The 11 was rounded, and it was used in every angle calculation. So, of course, our numbers are going to be off. Now, if you keep every decimal place, you should get more accurate numbers. Again, I'm marking for method. C. This time we're not going to be using cosine law right off the bat. This time we can use sine law. So I'm going to call this angle theta. There we go. Angle theta. And I'll call this side A, side B. I will look for angle theta first, because that is the same method we have been doing so far. Actually, I can't. I don't know enough. I won't be able to. I'm going to look for side B first. Side B, the opposite angle is sine over 79. Now, you absolutely can flip the sine law like this, as long as you flip both sides. I always write it so if I'm looking for an angle, I have the sine angle on top. If I'm looking for a side length, I have the side length on top. Saves me one little step later on, makes it a little bit easier for me. So whatever I'm looking for, I put that one on top, and I put the corresponding angle or side length underneath. So multiply both sides by sine of 79. So that gives me 13 sine 79 over sine 37. And that will give me 13 sine 79 divided by sine 37. Which gives me, call that 21 centimeters. Now on the other ones, I did not use units. This one I did. So I did want to see some units in here, but I was not very stingy with that. So now we have enough information to look for theta or A. In this case, we could do 180 minus 79 minus 37 equals theta, and we would get 64. Again, this whole question, I asked you to use sine and or cosine laws to solve each triangle. So even though I did not use either of the two laws to find this angle here, I did use a sine law to find side length B, and I am about to use a sine law to find side length A. So if you did something like this, I'd be perfectly happy with it. So again, if I'm looking for a side length, I'm going to put that on top. Opposite angle is 64. And I will use the 13 and sine 37 again. I always try to use the side lengths and angles that have been given, especially if they come in a pair. It guarantees that your work is going to be just a bit more precise, but truly doesn't matter. Could have chosen side B and 79 degrees. Doesn't matter. Multiply both sides by sine 64, so I end up with 13 times sine 64 over sine 37. A is equal to then sine 13, and that rounds down to 19, yes. 19 centimeters. That is part C done. D. Again, no cosine law right off the bat, because cosine law would require me to have this missing side length right here. But I don't have it. So, solving this, I do have a side length and an angle that are opposite from each other. So I'm going to start with a sine law. I will call this side length D. That's what question we on. That's what question we are on. Words are hard. Angle theta, angle phi. That's what we're looking for here. I will start by looking for angle theta, because that is opposite from the side length that I do know. So, angle theta, sine theta over 20 equals sine 110 over 55. Multiply both sides by 20. And take the inverse sine of both sides. Oops, did not mean to accidentally click the eraser there. And the sine inverse of 20 sine 110 divided by 55 gives us, that rounds up to 20 degrees. It's 19.98, a bunch of other decimals. I'm rounding that to 20. So, to find angle phi, I'll use my shortcut that I think I originally said I wasn't going to be using, but it's much quicker. And I'm still doing plenty of sine law and cosine law here, so I think this is good. 180 minus 110 minus 20. That gives us 50 degrees for phi. Lastly, I believe we must do a sine law to find side length D. So I will go D over the sine of 50, because phi is 50, and that's the opposite angle. And again, I'm going to use the opposite side length and angle that have been given, which is 55 and 110. So D is equal to 55 times the sine of 50 divided by the sine of 110. And that will give us 55 sine 50 divided by the sine of 110. Gives us about 45. Wow, that was not a nice 5. About 45. So, that is question 6 done. Longest one on the assignment. And the final page. Now, I think I forgot to number these, so this is question 7. This one is question 8. I just forgot to add the numbers. Sorry. Question 7, part A. Rewrite the following numbers using scientific notation. Okay, so I'm moving my decimal 3 places, 1, 2, 3, to the right. So I know I'm going to have 1.5 times 10, and it is a negative 3, because I'm moving it to the right. B, my decimal place is moving 1, 2, 3, 4, 5, 6, this time to the left. 2.73 times 10 to the 6. So, I guess I will box my answers because that is what I've been doing so far. So, scientific notation, you count the number of places you move your decimal point. If you move to the left, it's positive. If you move to the right, it's negative. and that is that number of times you move, and the positive or negative is the exponent you put on the 10. Otherwise, not too bad, I hope. So rewrite the following numbers using engineering notation. So this means scientific notation, but with multiples of 3 in the exponent. Now, I did not give you any units at all. Some of you wrote different prefixes as well. So some of you wrote 460 micro, which I gave you a mark. It wasn't exactly what I was looking for, though. I was looking for something more along the lines of 460 times 10 to the negative 6. That is more what I was looking for. But if you wrote 460 micro, I was fine with that. I didn't give you units, so I wasn't expecting anybody to write it like this, to be honest. So because of that, I gave you the benefit of the doubt, gave you the mark anyway, because this prefix means times 10 to the negative 6. To actually solve the problem, though, our decimal point moves 1, 2, 3, 4 points normally. So normally we would get, in scientific notation, 4.6 times 10 to the negative 4. Now, I would have given you 0.46 times 10 to the negative 3, or 460 times 10 to the negative 6. I would have taken either one. Both of them followed the fairly loose rules of engineering notation that we went over in the first week. So I would have taken either of these as a solution. And as said earlier, I did also take this as a solution, because I didn't tell you not to do that. 8 times 10 to the positive 5. So we could say 0.8 times 10 to the positive 6 as a possible solution. Move the decimal once to the left so that we can increase the 5 once, and that would be completely valid. Or you could say 800 times 10 to the 3. I would have taken either solution there. Question 8. For the following, determine the number of significant figures and list the correct SI units. A few people forgot to list the correct units. I did not ask you to convert the number to reflect what the new unit is. I just wanted you to tell me what the SI unit was. We'll do plenty of those conversions later in the course. So in this case, we have some leading zeros, we have some numbers, and we have a trailing 0. In this case, we are only going to count as significant figures anything that's not a 0, so the 4, 5, 6, definitely significant, and that trailing 0 as well is significant. Sig figs. So 4 significant figures. That is what sig figs is going to be standing for there. If you want to know why, please refer back to all of those significant figure rules that we went over in the first day there. And here we have grams as our unit. The SI unit I should say the word unit. Unit for mass, that is what grams measures, is the kilogram, or kg. Okay. So, in this case, we have 3 significant figures. That 0 is not leading, it's not trailing, it is in the number, so we have 3 significant figures here, based off of the significant figure rules we went over earlier in the course. And the units for distance, so SI unit for distance is the meter. Now, I did not specify, but I was hoping that I would see meters squared, because here we have kilometers squared. I gave you the mark if you just said meters, though. So I would have taken both. And that is the end of this solution video. Again, if you have any questions, ask me in class, email me. You know how to reach me by now, I hope. If you don't, let's chat about it somehow in class. Okay, thank you for listening. Thank you for watching.